Good morning, students. Welcome back to the Geometry online session. This is the 11th session on quadrilaterals, and in this session we are going to learn practice set 5.5, and this will be the last session on this lesson. Okay, so let's start with the revision of previous session. So in the previous session we have learned about the midpoint theorem. Yes, so what is the statement for this midpoint theorem? Yes, the segment joining midpoints of any two sides of a triangle is parallel to the third side and half of it. Now you have to explain this. How to explain this? With the help of diagram. So first we have to draw a triangle. Here I have drawn triangle ABC. In this triangle, what we have to consider? We have to consider midpoints of any two sides of a triangle. So here I have considered point P is the midpoint of seg AB and point Q is the midpoint of seg AC. And if I join these two points, I will get a segment PQ, and this segment PQ is parallel to the third side of the triangle, that is side BC. That means seg PQ is parallel to seg BC, and also this PQ is half of BC. Okay, so let's write down this in the word. If in triangle ABC, point P is the midpoint of seg AB and point Q is the midpoint of seg AC, then we can say that seg PQ is parallel to seg BC and PQ is half the length of BC. Okay, so I hope you are cleared with the midpoint theorem. If you have any doubt regarding this, you can watch the previous video. Okay, after that we have learned about the converse of midpoint theorem. Now we have seen that in the converse we have to consider the opposite statement. That means here we have to consider that if a line drawn through the midpoints of one side of a triangle and parallel to the other side, then it bisects the third side. That means in this triangle ABC, point D is the midpoint of side AB and line L passing through the point D and parallel to the side BC intersects side AC in point E. Okay, then we can say that AE is equal to EC. That means this point E is the midpoint of side AC. Okay, this way we have to explain this converse of midpoint theorem. Okay, I hope you all have understood what is the difference between midpoint theorem and its converse. Okay, now let's try to solve practice set 5.5. So this is the first question. In figure, points X, Y, Z are the midpoints of side AB, side BC and side AC of triangle ABC respectively. AB is equal to 5 cm, AC is equal to 9 cm and BC is equal to 11 cm. Find the length of XY, YZ, XZ. Okay. So first here we have to draw a diagram. This is the triangle ABC and it is given that point X, Y, Z are the midpoints of side AB, BC and AC. So let's write here X is the midpoint of AB, Y is the midpoint of side BC and Z is the midpoint of AC in triangle ABC respectively. Okay, then what we can say, if midpoint is given and the length of side is given, so can we apply here midpoint theorem? Yes, we can apply. So let's write here. So here first we have to find length of XY. So length of XY is equal to half the length of AC. Okay, we have seen that if X is the midpoint of AB and Y is the midpoint of BC, then this segment XY is parallel to the third side, that is AC, and it is half of it. That means length of XY is equal to half the length of AC. Reason you will write as midpoint theorem. Now let's substitute the value here. Length of AC is given here 9 centimeter. So therefore half into 9 is equal to 4.5 centimeter. So length of XY is 4.5 centimeter. Okay. Now we have to find length of YZ. Now how will you find length of YZ? Now here if you observe this figure, point Y is the midpoint of BC and point Z is the midpoint of AC. Then this segment YZ is parallel to segment AB and it is half of AB. Yes, so let's write here. Length of YZ is equal to half the length of AB, and reason you will write as midpoint theorem. Now let's substitute the value of AB. AB is 5 centimeter. So here you will get half into 5, that is equal to 2.5 centimeter. Okay. Now we have to find length of XZ. Now how will you find out? X is the midpoint of side AB, Z is the midpoint of side AC, and this segment is XZ is parallel to side BC and it is half of it. Okay. So therefore you will get here length of XZ is equal to half length of BC. Write reason as midpoint theorem. Now length of BC is 11, so you will get here half into 11, that is equal to 5.5 centimeter. Okay, so we got the values of lengths of XY, length of YZ and length of XZ. So let's write the final answer here. Final answer is length of XY is 4.5 centimeter, length of YZ is 2.5 centimeter and length of XZ is 5.5 centimeter. Okay. So let's move on to the next question now. In figure, quadrilateral PQRS and quadrilateral MNRL are rectangles. If point M is the midpoint of side PR, then prove that first one SL is equal to LR and second one LN is equal to half of SQ. Okay. So let's start with the solution here. What is given here? Proof. Quadrilateral PQRS and quadrilateral MNRL are rectangles. It is given to us. And what we have to prove is SL is equal to LR. That is SL is equal to LR. That means we have to show that point L is the midpoint of side SR. Okay. So how to show that? Now if you observe, these two are rectangles. And we know that in angles of a rectangle are of 90 degree. So this angle S and angle L will become 90 degree. Therefore, angle S is equal to angle L is equal to 90 degree. Reason is angles of a rectangle. Now, if these two are 90 degree, that means these two are equal. And if you consider this line SP or segment SP and segment LM as a parallel lines and SR as a transversal, then these two are corresponding angles. Yes, so you can write here angle S and angle L form a pair of corresponding angles on sides SP and LM when SR is their transversal. Okay, and we know that corresponding angles are congruent. Therefore, we can say here seg ML is parallel to seg PS. Okay, write this equation as equation 1 and reason you will write as corresponding angles test. Okay. Now, you have to consider this triangle PSR because we have to show that point L is the midpoint of side SR. Okay, and we know that point M is the midpoint of side PR. Okay, so if you show this line LM is parallel to SP, then by converse of midpoint theorem you can show that point L is the midpoint of SR. Okay, so let's write here in triangle PRS, point M is the midpoint of side PR and seg ML is parallel to seg PS. Okay, so therefore by converse of midpoint theorem, point L is the midpoint of seg SR. Now point L is the midpoint, that means we can write here SL is equal to LR. Hence we have proved the first part. Now let's see the second part. Here similarly, if you consider triangle PRQ, in this triangle also we can prove that point N is the midpoint of seg QR, because we know that here point M is there and M is the midpoint of PR. Then if you join this segment MN, then this will be parallel to PQ, and if it is parallel to PQ, then N will be the midpoint of RQ. That way you have to prove. Okay, so write this equation as equation 3. Now you have to consider one more triangle here. In triangle RSQ, in this triangle what you can say, point L is the midpoint of seg SR and point N is the midpoint of seg QR. Therefore you can say here, by midpoint theorem, if you join this segment LN, it will be half the length of SQ. Okay, so this is your second proof. Now let's move on to the next question. In figure, seg PD is a median of triangle PQR. Point T is the midpoint of seg PD. Produced QT is intersects PR at M. Show that PM upon PR is equal to 1 upon 3. Now here one hint is also given. Draw DN is parallel to QN. So here you have to draw one segment DN which is parallel to segment QM. Okay. So let's start with the solution. So here first we have to consider triangle PDN. In this triangle we know that point T is the midpoint of seg PD. Okay. So if you show that TM is parallel to DN, it is also given. One hint is given here. Draw DN is parallel to QM. So here TM is parallel to DN, and by converse of midpoint theorem we can show that point M is the midpoint of PN. Okay. So let's write here. In triangle PDN, point T is the midpoint of seg PD and seg TM is parallel to seg DN, because we know that Q, T and M are collinear points. Okay, because here in the question itself it is given that produced QT intersects seg PR at M. Okay. Now by the converse of midpoint theorem we can say that point M is the midpoint of seg PN. Okay. Now if M is the midpoint, that means PM is equal to MN. Write this equation as equation 1. Okay. Now you have to consider triangle QMR. In this triangle what you can say, point D is the midpoint of seg QR, and we know that seg DN is parallel to seg QM. Okay. So we can write here, by the converse of midpoint theorem, point N is the midpoint of seg MR. That means MN is equal to RN. Okay. Write this equation as equation 2. Now here from equation 1 and 2, what you can write here? PM is equal to MN is equal to RN. Okay. Write this equation as equation 3. Now PR, if you consider this segment PR, you can write here PR is equal to PM plus MN plus RN. Okay. Reason is points P, M, N and R are collinear points. Okay. Therefore PR is equal to, now we know that here PM is equal to MN is equal to RN. So instead of MN and RN you can write here PM. So you will get here PM plus PM plus PM from equation 3. So therefore PR is equal to 3 PM. Therefore PM upon PR is equal to 1 upon 3. So I hope you all have understood this answer. So now let's see the assignment question. In figure, triangle ABC is an equilateral triangle. Point F, D and E are midpoints of side AB, side BC, side AC respectively. Show that triangle FED is an equilateral triangle. Okay, so this question is very simple one. I know you all can solve this. So with this, I will end this session here. Thanks for watching this video. We will meet in the next session with the new lesson. Okay.